Going on, guys? Mr. C here with lesson 13.1. Going to be moving to chapter 13. So 13 actually doesn't have much to do with geometry. It's all about probability and statistics. So this will probably be our final chapter. I don't think we'll get into anything else outside of this. So we'll end it with probability. Typically, probability is not seen as too difficult. It's pretty straightforward, but we're going to stick with some pretty simple stuff today, and then might get into some more complicated stuff later on in the chapter. So let's talk about experimental and theoretical probability. Most of everything that we're going to be doing is all theoretical probability. If you mention, or if the book mentions experimental probability, what it's talking about is like an actual experiment. Like if you went and flipped a coin 10 times, okay, the experimental probability would be whatever that outcome of that is, where theoretical probability would just be it's always 50-50. It's going to be heads or it's going to be tails. Experimental probability is based on an experiment that happened and doesn't necessarily follow theoretical, but pretty much everything we're going to be doing is going to be all theoretical probability. So let's go ahead and start out with what probability even is. Basically, we write it like this. Capital P stands for probability of, and then inside parentheses we have some event. So the probability of an event is equal to the number of favorable outcomes, meaning what are we talking about? What's going to be favorable for this event to happen? Okay, so the number of favorable outcomes over the number of total outcomes. So favorable over total is going to be our definition for probability. So if we were dealing with a 6-sided die, okay, let's find the probability of rolling a 2. Okay, rolling a 2. So if we had a 6-sided die, okay, there's 6, 1, 2, 3, 4, 5, 6. Probability of rolling a 2 is there's only one favorable outcome, there's only one 2, and there's 6 options. Okay, so the probability of that would be 1 over 6. Right? For B here, probability of rolling an even is there's 3 even numbers. There's 2, 4, and 6. So that would be 3 out of 6, or we can reduce that to 1/2. So the probability of rolling an even is 1 to 2. If you want, you can do these as percents as well. 50% is good, but fractions are fine too. So 50%. Probability of not rolling a number greater than 5. So let's think about that. Not rolling a number greater than or equal to 5. So that means we would want to roll a 5 or 6, right? So that's 2 outcomes out of 6. We can reduce that to 1/3, which is about 33.3%. Okay. So again, not rolling a number greater than or equal to 5 would mean rolling 5 or 6. So that's probability for those. Going to look at one more example. This is going to be a very, very short lesson today. Let's look at this. So a very common problem in probability is they always put marbles in a bag or marbles in a jar of different colors. I don't know who are these people that collect these marbles, but they exist in the math world, and we're going to study these strange people with their strange habits. So let's say we have a jar of marbles. All right. And I want to find the probability of not picking a green one. So looking at the picture, let's first add them all up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And I'll just double check because I don't remember how many I wrote, how many I made. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and indeed 23. Okay, so we have a total of 23. Now, if we're doing not green, another word for that is called the complement. It's called the complement. Okay, it's a keyword. The complement of picking green would be picking not green or not picking green. So Another way we can find that, rather than adding up all the blues and all the reds, one thing we can do is take all the green, 1, 2, 3, 4, 5, okay? And if we want to find the complement of picking green, which would be 5 out of 23, one thing you can do is take 1 and subtract the probability of picking green, okay? Since there's 5 green, again, 1, 2, 3, 4, 5 out of 23. If you want to find the complement of picking green, which is technically picking not green, you can do 1 minus that, okay? 1 minus this. So 1 minus 5/23 is 23 23rds minus 5 23rds. 23 minus 5 is going to give me an 18 23rds, okay? So if we want to find the probability of not doing something, okay, which is the complement, it's called the complement of doing something, we can just do 1 minus this, 1 minus the probability of picking green, to be clear. 1 minus the probability of picking green will give us the probability of not picking green. Okay. All right. That is all I have. That's it. So, yeah, I will talk to you guys later. Let me know if you guys have any questions, and I'll see you next time. Peace.